Здравствуйте, спасибо, что пришли.
Hello, dear friends. Thank you so much for coming.
Действительно, Иван Балагуров.
Indeed, it's no mistake. I am Ivan Balagurov. I'm a senior data engineer at Kaspersky Lab. I work for the group that develops methods for analyzing and detecting cyber threats. I'm also responsible for providing data to train ML models. And I'm here today to talk to you about pipelines, about training ML models, retraining ML models, why you would want to do that, what kind of risks you can run into if you don't do that, and finally, what can you run into if you do that. So if you are an ML ops engineer, ML engineer, data engineer, you could be interested in what I've got to say, as well as, general fans of machine learning.
Так, модели машинного обучения
ML models
заняли свое место в индустрии
have
информационной
already taken a pretty sweet spot in the information security industry.
Применяем различные
At Kaspersky Labs, we are applying various types of ML models to automate internal processes as well as detecting cyber threats. However, development of ML models is characterized by some issues I'm going to cover a bit later. Also, in my presentation, I am planning to refer to some machine learning models our team is developing, and these models are designed to detect cyber threats. Now, why is it important to retrain ML models? Well, in our case, we will be talking about models that detect cyber threats. And for us, the answer is such that new cyber threats emerge every day. Cyber criminals, keep coming up with new ways of hacking your precious systems. So models need to be retrained on up-to-date data. Let me give you a simple example. There was a time when crypto miners just emerged. So if your model had been trained before that, it would not be able to detect crypto mining software. Now, what are the consequences of detection ML models getting outdated? Now, an outdated ML model obviously will detect less than it should. Now, what this means is that our clients will not be protected well, which means that, they will be unhappy with our services, we will lose them as clients, we will lose out on the money they're bringing. However, ML model development is actually characterized by a high degree of uncertainty. Nobody guarantees success. So it's an area of elevated risk. It works this way due to a number of factors I will list later. But one of the key reasons to be concerned about the validity of your ML model is such that, we know exactly what the end result should be. We need to check so many hypotheses as we develop our ML model. And, we want a functional ML model so badly that we feel like under-prioritizing the infrastructure around it. So if you badly want this kind of result, you won't really be thinking about the need to retrain your model sometime in the future. Now let's consider the usual process which underlies development of a new ML model. So, development from scratch. Where does it start? Usually, it starts with you talking to the client. The client comes to you saying, I would love to detect certain types of files. I want to be able to distinguish good files from bad files, and I want a certain level of accuracy to that. Now, in our case, we actually had a project which specified that the false positive rate should be at the level of 10 to the power of -5. At this stage, we set criteria, and then we go looking for data. Data search is a pretty complex, comprehensive stage, because very rarely will our clients come in bringing their own data sets. In the best of cases, they will tell you where to look for such data. So once you've found the data, you have to collect it, order it nicely. And next, you need to analyze the data, you need to process the data so that your ML algos word into action. So once you've done that, you can go to the stage of model training. So you can select the model architecture, its parameters, hyperparameters. You can see a backwards arrow here because it's a cyclical process, meaning that as we are training the model, we will be playing with different hypotheses, and for each hypothesis, we will need a different data set. So we go into an experiment, we see if it works or it doesn't. If it doesn't, we go back and we repeat this, or we iterate this process until we get a model with a level of quality we consider tolerable or sufficient. Now, if we have a test environment for testing the model on real data, even better, we test it. But that's not a given. So eventually we get to the stage of developing a report, we do the charts and tables there, and then we meet our client. If the client likes it, we will implement the new model in the production environment of the client. If they aren't, well, we don't. It was on purpose that I haven't said anything yet about the red arrows. Naturally, our development process can stall or be terminated at every stage, designated with the red arrow here. Now let's talk about specific stages in ML development. ML model development, I'm sorry. And the first stage, as you remember, is consultations with the client. So very often clients will come in and tell you, we want some machine learning because obviously it's fashionable, it's trendy, it's all the rage, and investors really fall for any mention of ML in your annual report. So most clients don't really know what kind of a machine learning they need, but they're absolutely certain and adamant that they need one. So, as a professional, you have to explain to them what kind of machine learning are available out there, what kind of criteria and metrics they're associated with, and trust me, it may easily take quite a lot of time. Like I said, clients usually walk in without data. And that's a major issue.
Примите то, что к вам никто никогда не придет с большим мешком данных и скажет, вот вам.
Believe me when I tell you that nobody is really going to come to your office with a huge sack of data saying, now go train my model. That simply won't happen. Now, since clients don't really know much about ML, they don't really know how to assess the quality of the ML model. And since they do not give you this sack of data, the data science team will need to go looking for the data. And that creates several issues. A, the data can be non-existent. Now imagine that you've been told to do some, file detection, maybe malicious logic detection, and you don't have such files. Or maybe, the client wants you to be able to detect a particular, dangerous new malware, and there are not enough instances out there in the wild yet. Moreover, you can find some data, but it's not marked up. And since it's not marked up, even the best ML algos, those supervised learning algos, will not work for you. Well, you can do unsupervised learning, which does not require markup. But in most cases, you will want to do supervised learning. So at this stage already, the whole project may come to a screeching end. Data collection. Now imagine you have found the data. And this data obviously will need to be stored somewhere, preferably on your side. Why is that? Well, you may have data today, but not tomorrow. Imagine that you have a data feed, and this data feed stores data for the previous week, and then, everything gets wiped. So if you fail to collect data for this week, it's gone next Monday. And the amount of data, as well as data quality, will primarily drive how successful you are in training your model. Like 95% of your success is determined by data. And data needs to be stored, preferably in a distributed storage. Well, you can use S3, you can use other services, but it's a good idea to place it someplace secure. Note that data collection is an engineering task. Although, we are researchers, we are a team of researchers in ML, but we end up addressing those engineering challenges, and we don't really like doing that. I have merged the next two steps here because they seem to complement each other. Like I said, data analysis, data processing, model training are complex, iterative processes. We have to test so many hypotheses. Now, there is here the following obstacle. Training can take a long time. So imagine you have 1 terabyte of data. In order to select the right sample for the model to be trained on, you can easily spend several days, and then the training itself will take another week, and that's just for one hypothesis. So imagine you spend several months in consultation and data collection, and then you can easily get stuck on this stage. And nobody guarantees success. You can easily end up with having not a single algo or not a single hypothesis validated. So this is where you can also can come to a screeching end. And people resent that, obviously. So imagine you've trained your model and you like the quality, so you seem to be successful. So this is the post-processing stage. Like I said, you save the model to some repository, and ideally you would want to test it in a test environment. You can easily be proven wrong at this stage. It can easily happen that as you were doing the learning process, the training process, models seem to be very good. And when you expose it to real data, it can prove to be much worse. Why can this happen? Now, in all probability, it's because of poor markup. You will probably need to re-mark up your data. It's a shame, because imagine you've already invested 6 months into doing that, into training your model. You have a model that seems to be nice and well-trained, but in a test environment, it flounders. So you've written your report and you start discussing the results with the client. There is no guarantee at this stage that your model will go into production, even if it shows good quality. How come? Well, like I said, clients usually know little about ML. So maybe they'll tell you we don't like the false positive rate of your model. And maybe they didn't even tell you that they have this expectation of you at first. Now, we had this case that the model started detecting things which the client didn't think, it should detect. So it was finding kind of student papers on cybersecurity, which should not really be considered malware. So imagine you've gone through all the stages and the model is up and running in the production environment. So we have the model, he has been trained, he has been deployed, it is already showing some good results and generating quite a lot of money. Well, this is a stage where clients are usually happy and developers get their annual bonuses. However, there are artifacts from this development project, such as poorly written Python scripts and the other stuff you forget in developers' laptops, in various repositories, and what have you. So you might be thinking, now this is the real success. Or is it? Usually, like 12 to 18 months later, as new data gets accumulated, other changes happen. So like I said, there is new data now, which your model has never heard about. So the quality of the model has gone down. It simply cannot detect those new objects because he's never seen them. So clients will come, tapping on your door saying, how about we retrain the model? And by this time, your team may have changed. Or maybe the team has got leaner. Some people have left, new ones have not come, or maybe they have come, but they know nothing about the old model. And even if the team is the same, it may very well happen that your teammates have completely forgotten what's under the hood because, they've been busy working on some other research projects, training other models over this time. And this is something that finally brings us to the subject of digital archaeology. Like, we need to go back to the pipeline that we previously developed, restore it, and retrain the model.
Первый, культурный слой, с которым мы сталкиваемся, когда мы начинаем свои раскопки, это сбор и обработка данных.
So, the first layer we go into is data collection and processing. So it's done through task scheduler, or maybe something else, depending on the operating system that you prefer. And you know what? It's a workable solution. Everybody liked it. The problem, however, is that monitoring such a solution can be difficult. All right, so it's done through a run if you're using Linux. Cron, sorry. So if you do not have notifications built into the pipeline itself, you will never learn that your robot has gone down, for example. Now, we had those cases when, from the moment our robot, started experiencing difficulties, the data schema in the database changed, and because of that, it suffered. And it would take us like 6 months to discover it. So we lost a lot of data over this time. It was incidentally that we discovered that there were issues. So somebody needed this data from the data warehouse. And, they discovered that the data wasn't even there. Why is this solution suboptimal? Now, simply by looking here, can you tell me which component follows which other component? Because in a pipeline, you have a graph, or at least you should, but if you look at this one, it's pretty difficult to say what the linear relationship is. You can say, well, we can use systems like ITIL compliant. For example, we are using Airflow. Did I say ITIL? No, ETL, actually. And Airflow does cover like 80% of our needs. Let's dig a bit deeper. Let's look at the code. Now, the problem we are seeing here is the way the code is structured. Now, the initial code of every pipeline component will be stored in a separate branch. How come? Well, the researcher team doesn't really know or doesn't really like to use Git, which means that for every component, for every research study, you will have so many branches. And the code in them will certainly be pretty redundant. They will be copy-pasting code. When people leave, and nobody will remember which branch stored the initial code. What's worse is that the code in the production system is not aligned with the code in the repository. It can happen that, somebody changes something manually in the production system and forgets to commit it to the repository. So even if you find the code in the right branch, nobody guarantees that it's the latest version of the code. Naturally, the solution here is to store the code in the master branch in the repository. I hope I'm not telling you anything new, and still there are people who don't do that. Next, you can use CI/CD systems to deploy your code into production, so that you have code consistency between repository and production system. Also, you can introduce changes through pull requests, and also do change review in those pull requests, because after all, you may want to be double certain that these are the right kind of changes. Now, if we drill a bit deeper, we will encounter the following problem, which is code redundancy, or having the same code across different repositories. So imagine you have two repos. One stores the code for training the model, and the other stores the code for model inferences, which is like a wrapper for the model running in your production system. Now, both repos hold the same component for, say, feature processing. The only problem is that they're slightly different, while they shouldn't be. How could this happen? Now, in all probability, the researcher, having trained the model, did some post-research. So he decided to fine-tune the model a bit more. He introduced some changes to the training repository, and he forgot to reflect those changes, or he didn't have the time to do that with regards to the repo which contains the model inferences. And thus, the discrepancies came into life. So when you go back to this model or this pipeline, it's pretty difficult to see what should be seen as the source of truth. Which of the two codes is the right one? Logic and common sense should help you, but do not count on them helping you in every situation. Which means that it's certainly a good idea to run your project using the same repository. If you are sharing your code between different projects, now it makes a lot of sense to put this shared code into modules available through distribution systems. Now we use Python, that's why we are using PyPy. So we use it to distribute Python packages. Next one is about libraries and version control. So imagine that you have a repo. In your repository, you have committed several model versions. Now, these versions, they also have feature pre-processing modules. So they're associated with some versions, 0, 1, 2, and so on. Which of these versions is the latest one? Which is running in the production system? If you don't have CI/CD, if you do not have pull requests, how do you do that?
Что нужно делать в этой ситуации? То есть это просто
So what should you do?
в своей библиотеке.
Well, first solution is to do proper version control.
С каждой версии пришло.
Do README files explaining what the differences between versions are. It's also a good idea to do this version control for dependencies.
Это файл с зависимости одной из
The screenshot of them
классификатора.
shows dependencies for a classifier that we have.
Это библиотека для
So there is XGBoost there shown. It's a library we use for model training. Now, it doesn't show a version number. And the problem is that the model that we had previously, it had been trained using XGBoost 0.82, but starting from version 1.0, model format has changed. So at best, your model will not start. It simply will not load. Like you're trying to load the model file, and at best, it won't run. In the worst case, the model will run and will mislead you. It is very difficult to notice that. So please, 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 always indicate versions for the dependencies. Now, this is a particular pain point for me. Data science teams really love this tool.
Jupyter.
I mean, Jupyter.
Используют его вместо полноценного IDE.
And they use it instead of a full-blown IDE. Well, sometimes they use a Notepad++. I hope it's a deviation of a particular team, though.
Лишь несколько вольностей, которые себе они
So
позволяют.
shown here
Давайте сверху пойдем.
are some of the things
Они не
they commit.
команды, да, то есть они не
So these are DS, data science teams. So, for example, they can fail to do kind of a standardization or type indication for the parameters they're using. Take, for example, file buffer. What is file buffer? Is that a buffer, the buffer itself, or is that a path to a file containing a buffer? What is it? Now, position seems to make some sense, but look here, the name of the variable encodes its type. Why would you do that if you can indicate it clearly?
Из-за того, что из-за характера ресерчерской работы, значит,
So the nature of the work done by researchers
очень много библиотек.
is such that so many libraries
Вот вы представляете,
get used.
включается одна библиотека, вторая библиотека,
So
третья.
imagine your Jupyter book with so many libraries invoked there.
Из-за того, что вот код постоянно меняется,
And since the code keeps changing,
параметры стали уже, ну, как бы
people tend to forget
актуальными.
that some parameters are no longer up to date. And
Того, что у вас не используется,
since,
у вас вот это
syntax doesn't get highlighted here, and nobody really reads this stuff carefully, all this shit can easily go into production.
research, они могут не
And the libraries that were used at the research stage are often not used in production, but they will still be up there running.
Отдельная история это про имена переменных. То есть кто-то застрял в
A separate pain point is the names of variables. So, some people still remember the 1980s when the length of variables was limited. Now, what's J2? What's J1? Now, what you see here is pretty complex logic. I'm sorry, it's pretty difficult to read. And when the names of variables are such,
Это еще становится сложнее. Вот
it becomes even more of a challenge.
и, есть такая вот вещь, как проверка орфографии. Это, конечно, не критично, но
Also, spell checking. Now, you can say that it's not a critical thing.
какое-то слово,
But you know what? If you're using a particular word
то есть вот у вас
in your data schema,
слово сканер, оно пишется с двумя,
such as scanner, well, usually English users use
то вы
two
потом
ends
это очень
here.
сложно исправить, потому
And
что у
if
вас
IDE doesn't highlight it for you, it will be difficult to correct it in the future because, you will be using this schema in so many places.
тестирование кода. Докопались мы до
Code
тестирования
testing.
кода, и здесь вообще могла быть картинка с тестами, но
I could have shown here an image of the tests. But you know what? The problem can be that you don't do code testing at all. No, certainly I am exaggerating. Some code testing is done, but certainly not as much as should be. Or how about I play the role of a devil's advocate? You know, the nature of what researchers do around ML models is such that, you know, they're not really expected to develop proper tests as you would for proper software. Certainly, I'm not insisting on that. But wouldn't it be nice for us to have tests that would at least transform data, creating features for the model maybe? That would really save you. If data format changes, for example, then you would instantly know where the problems sit. Next one is resource consumption monitoring. Nobody usually takes note of the memory or CPU consumption while you are developing your component. Although, you know, the system will be getting bigger, the data sets will be getting larger. Why is this a problem? Well, because 18 months later, when you go back to this data component, in all probability, your robot will be downed with an out-of-memory mistake. You could never imagine that when you started it all. We actually had this case. We had a robot. It would take a Parquet file from HDFS, would also take some JSON updates, would put them all in the memory, merge them, make a snapshot, and would then would upload this Parquet file back to HDFS. Now, the problem was that those updates initially were 5 gigabytes, and they became 30 gigabytes. And the robot in our server became bulky, started, you know, elbowing other robots, and would become unstable. Well, we noticed that, and rather than doing in-memory merge, we first transformed it into an SQL database, and then we would work not with the operating memory, but rather with the drive. That cost us some time in terms of performance, but this way we made sure the size of the robot would not exceed 300 megabytes, and now we understand that it can easily manage any load. And indeed, scaling the drive size is much easier than scaling the memory. So when you develop any components, please consider that you can easily get more data than you expect. Now, the final stage is post-processing for the model after it has been trained. So, you've done your work. You've invested several months in training the model. The model already is of some probably decent quality. Your data scientist is already tired. Like, he believes he has overcome the biggest challenge. So all this stuff about, you know, saving the model, checking the model, doing the report, well, your data scientist, I guess, will do that, but without too much passion, because this is the boring part of what data scientists do. In particular, I mentioned here this issue of having no repository for models. Like, imagine you've trained your model, you have a file now. Where does this file go? What happens at times is that this file simply stays in the developer's device. Well, you know, you sent it over a mail or whatever so that it's deployed in production, and that's it. And then your developer leaves. The laptop of the developer is wiped, and you lose the model.
Какое-то время нужно было эту модель как-то опять восстановить, что-то она...
And then the client comes in saying, would you like to
Через какое-то время
update the model, please?
вот модели у вас нет. То есть если у вас
And the model is gone.
централизированного...
Maybe it was, switched off in the production environment, so you cannot take it from there either. So if you do not have a centralized repository or storage place for your models, you can run into this issue.
Значит, нету вот этого централизированного хранения.
So if you don't have centralized storage, you've got nowhere to take it from. Like, you cannot find this model, particularly in an automated manner. And when you save the model, it's usually a good idea to do versioning. And this is true for the model as well as the hyperparameters for the model. And even better, to link it to the dataset. Now, your dataset can be huge. For one of our models, the dataset was 10 terabytes, just for a single model. So if that's HDFS, distributed storage, replication factor is 3, meaning it's 30 terabytes, and it just sits there. It's difficult to store it, but it's recommended.
Значит, какое решение вообще здесь может быть?
Now, what's the solution proposed here? Is to automate everything you can automate,
написание отчета, чтобы отчет тоже
including saving the model through the repository,
и по возможности
generating reports so that the reports don't get lost along with the model, using a version control system for the dataset, for the model. There are frameworks out there, but they are usually good if your dataset is relatively small, like several gigabytes, maybe a couple dozen gigabytes, but no more than that, certainly not hundreds. Now, what could be the conclusions that your archaeology efforts will support? As they say, luck favors those who prepare. Use Airflow and similar services because they will simplify your life immensely. Organize your code, keep it in the master branch, commit shared code to libraries, create a storage for the trained models, learn how to use IDE. That's important, I'm serious. Set up CI/CD once. Spend some time doing that, okay? It will give you a colossal boost going forward. Automate pretty much everything you can automate, particularly report generation, so that your reports are regenerated every time you get a new model. And do tests, okay? At least at the level of data transformation. Now, everything I've been talking about today should sound very simple. Like, if you're a developer, if you do classic development, this sounds like 101 course. You will be amazed that this is new to some people. But if you're a researcher, development is not your main responsibility, and that's how it should be, in fact. And therefore, I'm here preaching that you need to invest some time in configuring these processes so that you can go faster, you can run faster going forward. Now, we work in an area characterized by a high level of uncertainty and risk. If a particular model, for example, proves to be a runaway success, if you have configured everything, you will not really have to go through all these motions 18 months later, wasting so much time in digital archaeology. You know, sometimes you have to invest even more time in digital archaeology than you would in developing the pipeline first. So, create the right environment, configure the processes, and then things will be fine for you. You will be able to run faster.
Достижения нашей команды в переобучении ML-моделей, когда вот мы все эти процессы настроили.
Some achievements of our team after we have reconfigured our process is that we have order in our repos. Our processes are nicely configured. We have CI/CD, changes go through pull requests. We have proper code review. We have easy-to-understand pipelines. We can quickly respond to incidents. So if a robot goes down like a data collection robot, we learn about that immediately, not 6 months later. And model retraining has become very easy. It takes like 3 times less than before. And most importantly, we have time now for new studies. We can actually train more models because we have these supportive processes. Thank you very much for your attention. I'm done. Yeah, thank you so much. And if you liked it, please rate it using the QR code. And right now I'm going to ask you the questions we have collected using the bot. How do you control data quality, so to speak, for training purposes? How do you make sure that your model has not broken down? Are you using any sets of vectors? Well, like reference vectors. You know, all data labels come from analysts, from other systems of detection, for example. In other words, we're very serious about labels. So it can happen that the data is skewed, but we address that. And you're absolutely right, that's important. How do we address this problem that data collection is effectively an engineering task? How about having a data engineer on your team so that researchers do research and data engineers do engineering? Is it true that you can have a commercial development without the basic get flow? Yes, it can happen. You know, everything I've told you about is true not just for our team. It is true for the other teams I've been exposed to. No, I attended conferences and meetups, and this is what I'm hearing. And it's easy to explain. Imagine you're a researcher. You're a graduate of Moscow State University, maybe mathematics and mechanics department. You know a lot about machine learning, but you can do Python a bit. Like you can do Py and Pandas, you can juggle them a bit, the basic libraries, but nobody has ever taught you all those things. Get flow, requests. Nobody has told you how to name functions properly. Nobody has ever told you optimization. You don't think too much about RAM. Like you work in your table. And I think this is an issue, isn't it? So you need to spend a bit of time to learn that, to have at least some basic understanding of it. Thank you. How do you store and how do you track versions of your ML models? We don't have a specialized framework, but we have a process. Like I said, we have a dedicated storage for the models. We do versioning for the models. We take file hashes, including the inference files, the model files, and the hyperparameters. So, all right, and we also store the data set for some time, for several years usually. So as long as the model is in production, we will store it. Well, because we understand that people can come in asking, how come your model is detecting this, but not that? And we understand that answers to such questions are always in the dataset. You know, the model will not know something that's outside the dataset. So we will go looking into the model, into the dataset, I'm sorry. Thank you.